Hi everyone, this video is a sequel to my previous video. I'm going to show you how to find the coordinates of the center of the circumcircle of triangle ABC using two methods. The first method, we are going to use construction, and the second method, we are going to use simultaneous equations. So what is a circumcircle? Okay, a circumcircle is a circle which circumscribes a shape, in this case a triangle. So it's a circle which completely surrounds the triangle, in this case triangle ABC, in such a way that the vertices of triangle ABC rest on the circumference of the circle. So we want to find the center of the circle. So I'll show you how to find the center of the circle which circumscribes triangle ABC using, first of all, construction, okay? So let's dive into it. If the circle circumscribes triangle ABC, it means that AB, BC, and AC will be chords of the circle. So for me to find the center of the circle, I must find the point where the perpendicular bisectors of any two chords meet, okay? For example, in this question, I'm going to use chord AB and chord BC. So I'm going to find the perpendicular bisector of chord AB and the perpendicular bisector of chord BC using construction, and where the perpendicular bisectors of the chords AB and BC meet, that's where the center of the circle is located. So I'm going to start by constructing the perpendicular bisector of chord BC, okay, using this compass, okay. So first of all, I've chosen C as my center, and I open my compass so that it passes halfway of BC, okay. And then I'll construct an arc, another arc, without changing the position of the center. Still C is my center, okay. Without changing the radius, I will then choose B as my center, okay, and draw an arc which meets the first arc, and here also which meets the arc, the other arc, okay. So for me to draw the perpendicular bisector of BC, I'm going to draw a line which passes through these points of intersection, okay, of our arcs. Okay, so let me use this marker for you to see the points of intersection. Okay, there they are. So I'm going to draw a line through those points of intersection for me to draw the perpendicular bisector of chord BC. Okay, so the side length BC of the triangle will become the chord of the circle which circumscribes the triangle, okay. So this is the perpendicular bisector of the side length of the triangle BC. So it means here we have got an angle of 90 degrees, okay, and it passes through the center of the line BC, which is here, okay. So that's why it is called a perpendicular bisector. Next, I'm going to construct the perpendicular bisector of the line of the side length AB, okay, which is so B as my center. I'll draw an arc here, and then without changing the center, still B as my center, I'll draw another arc here, and then without changing the center, or the radius rather, so that you can see, let me use the left hand. Right, so the arcs intersect at this point, so let me use a marker. They intersect here and here. Okay, so I'm going to draw a line through the points of intersection of the arcs for me to draw the perpendicular bisector of AB. Okay, so this is the perpendicular bisector of AB. As you can see, the two perpendicular bisectors, that's of BC and AB, intersect somewhere here. Okay, so from construction we can see that if I draw the circle which circumscribes triangle ABC, it means the center of the circle will be at this point. So it's roughly the x coordinate is 4 and the y coordinate is 4. So the center of the circle from construction is about 4 semicolon 4. The y coordinate is 4, as you can see in the x coordinate 4. Let me show you how to draw the circumcircle of triangle ABC with the coordinates 4 semicolon 4, which is here, where the perpendicular bisectors meet. So this is my center of the circle, and I open my radius from the center to the point, either to the point A, okay, or to the point C, okay. So I'm going to draw the circumcircle of triangle ABC, okay. So you realize that the vertices of my triangle will lie on the circumference of the circle. The three vertices, that is the vertex at A, B, C, will lie on the circumference. Okay, so this is roughly my circumcircle. As you can see, the vertex at B here lies on the circumference, and C on the circumference, and vertex A on the circumference, with the center 4 semicolon 4. Okay, so let's proceed. I want to show you how to use simultaneous equations to find the center of the circle. For me to use simultaneous equations to find the center of the circle, first of all, I must find the gradient of the line AB and then the gradient of the line BC, which are my chords after drawing the circumcircle, okay? So gradient of AB, I'm going to use the formula M equals increase in y over increase in x. Okay, so my y2 is this one, so 1, and my 1 is 3, so 1 minus 3 over my x2 is 5, and my x1 is 1. So 1 minus 3 equals negative 2 over 4. So my the gradient of AB equals to negative half, okay, minus 1 half. After finding the gradient of AB, I must find the gradient of this perpendicular line of AB, okay? So let's proceed. So to find the gradient of perpendicular line of AB, which is this one, I'm going to use this property, M1 multiplied by M2 equals minus 1. So M1 is the gradient of AB and M2 is the gradient of the perpendicular bisector of AB. The product of the gradients of the perpendicular lines equals to minus 1. So in this equation here, my M1 is the gradient of the line AB, so it's minus half multiplied by M2, which is the gradient of this perpendicular line, equals negative 1. After solving this, you realize that M2, which is the gradient of the perpendicular line of AB, M2 equals 2, okay? Right now, I want to find the midpoint of AB, which is this one here. Okay, this is the midpoint of AB, so I'm going to use this formula to find the midpoint of AB. That's half of x1 plus x2 semicolon half of y1 plus y2. Okay, so my x1 plus x2, it's this 5 plus 1, so it's 1 plus 5 semicolon, and my y1 plus y2 is this one, 3 plus 1. Okay, this 3 plus 1 also divided by 2. So finally, the midpoint of AB, 1 plus 5 is 6 divided by 2, we get 3. Semicolon 3 plus 1, that's 4 divided by 2 side 3, semicolon 2 is the midpoint of AB, which is here. Okay, so this 3 semicolon 2, that's our midpoint of AB. So now let us proceed and find the equation of this perpendicular bisector of this line, which is the perpendicular bisector of AB. So we now know that this point is 3, 2. Okay, and we know that the gradient of this line is 2. So I'm going to use y equals mx plus c to find the equation of the perpendicular bisector of AB. Okay, so y equals mx plus c is the standard form for the equation of the straight line. Okay, so remember this point here is 3 semicolon 2, and the gradient of this perpendicular bisector equals 2. Okay, so I want to substitute the coordinates of this point as 3 semicolon 2 and this gradient of 2. I want to substitute these values into this equation. So my y here is 2, and my m here is 2 again, and my x is 3 plus c. So first of all, I want to find the c, which is the y-intercept. That is where this line cuts the y-axis. Okay, so it's 2 equals to 6 plus c. Okay, so finally our y-intercept, which is c, equals to minus 4. Okay, so the equation of the perpendicular bisector of AB equals to y equals to 2x minus 4. So that's the equation of this perpendicular bisector of AB. Remember that we want to use simultaneous equations to find the center of the circle which circumscribes triangle ABC. So now we want to find the equation of this perpendicular bisector of BC. So for us to find the equation of this line, we must first of all find the gradient of the line BC using m equals to increase in y over increase in x. Okay, so my y2 here is 5, and my y1 is 1. 5 minus 1 over my x2 is 7, and my x1 is 5. So finally, the gradient of the line BC equals to 5 minus 1, that's 4. 7 minus 5, that's 2. So the gradient of the line BC equals 2. Okay. Now we want to find the gradient of the perpendicular line of BC. Okay, so for us to find the gradient of the perpendicular line of BC, we are going to use this property m1 multiplied by m2 equals -1. m1 stands for the gradient of BC, and we discover that gradient of BC is 2. So 2 multiplied by m2, which is the gradient of the perpendicular bisector of BC, equals -1. Okay, after solving this, we realize that m2 equals minus half. Okay, that's the gradient of the perpendicular bisector, which is this one of BC. Now we want to find the midpoint of BC, which is this one here. Okay, so we are going to use this formula. Okay, half of x1 plus x2 semicolon half of y1 plus y2. Okay, so the midpoint of BC it's half of 5 plus 7, which are the x coordinates, semicolon, half. The y coordinates are 1 plus 5. Okay, this is half of 5 plus 7, that's 12, half of 12, semicolon, half of 1 plus 5, that's 6. Okay, so the midpoint of BC, which is here, is 6, semicolon, 3. Okay, so that's 6, semicolon, 3. And here the midpoint of AB obtained 3, semicolon, 2. So now we want to find the equation of this perpendicular bisector of BC, which passes through the point 6, semicolon, 3, and whose gradient is minus half. So we are going to use y equals mx plus c again. So I'm going to put values into this equation so that I can get the y-intercept, which is c. So I'm going to use this point 6, semicolon, 3, and remember that the gradient of this perpendicular bisector of BC is negative half. Okay, so my y in this case is this 3, so I'm substituting 3 for y, and my m, remember, its gradient is negative half, as we saw previously, and my x value is this 6, so I'm substituting 6 for x here plus c. Okay, so 3 equals to minus 3 plus c. So c, which is the y-intercept, equals to 6. Okay, which is somewhere here. Okay, so the equation of this line, which is the perpendicular bisector of BC, is given by y equals, and the gradient is minus half, x, the y-intercept c, that's plus 6. Okay, so I want to remove this fraction, so I'll multiply throughout using the LCM, which is 2 in this case. So it becomes 2y equals 2 minus x plus 12. Okay, simplifying further, it becomes x plus 2y equals 12. We realize that the equation of this perpendicular bisector of AB is y equals 2x minus 4, and the equation of this perpendicular bisector of BC is x plus 2y equals 12. So we want to solve the two equations simultaneously. So after solving the two equations simultaneously, where they intersect, which is here, that's the center of the semicircle of triangle ABC. So my first equation is y equals 2x minus 4. Shall call it equation 1, which is the equation of this perpendicular bisector of AB. And also my second equation, that's x plus 2y equals 12. I shall call it equation 2, which is the equation of this perpendicular bisector of BC. So we want to solve them simultaneously using the substitution method. So I'm going to substitute 2x minus 4 for y in the second equation, meaning where there is y here, I'm going to put 2x minus 4. So I'm going to rewrite the second equation as follows: x plus 2 multiplied by the value of y, which is 2x minus 4, equals 12. So here we get x plus 4x minus 8 equals 12. And then you collect like terms, and here we get 5x equals 20. So x equals to 4. That's our x coordinate. So we want to substitute 4 for x in the first equation so that we can get the y coordinate. Okay, so we'll rewrite the first equation as follows: y equals to 2 multiplied by 4, which is the value of x, minus 4. This gives us y equals to 8 minus 4. So finally, the y coordinate equals to 4. Okay, so the x coordinate is 4 and the y coordinate is 4. So meaning this center where the two perpendicular bisectors meet has the following coordinates: 4 for x coordinate, same colon 4 for the y coordinate. That's our center of the circumcircle. Okay, so guys, thank you for watching. I've shown you how to use simultaneous equations to find the center of the circle which circumscribes triangle ABC. Thank you for watching. Meet you in the next videos.